Okay, so let us now move on to a discussion of a very important and interesting phenomena known as the hydrogen bond. Now, what you'll find is that if you compare the hydrides or the hydrogen containing compounds of group 6 elements, starting with H2O, H2S, and then H2SE, which is hydrogen selenide, and H2TE, what you'll find is that as you go down that group 6, you'll find that certain properties start to vary. For one, the melting point, you'll notice, varies. It goes from 0 to minus 85 to minus 65 to minus 49. So therefore, there's a gradual increase from, well, actually there's a decrease from water to hydrogen sulfide, and then there is a decrease when you go from that to H2SE and then to H2TE. But what I really want to point out here is the boiling point variation. And what you'll find is that there's basically a decrease in the boiling point as you go from water to hydrogen sulfide to H2SE and then H2TE. All right. What you'll find is that the boiling points of water and the melting point of water compared to the other compounds in that group is relatively high, and it does not fit into the trends that of properties relative to the molar mass within the group, right? Because as you go down that group, the molar mass increases. But for some reason, water has a high boiling and melting point compared to the others, even though its molar mass is comparatively less. So, even though water has the lowest molar mass, it has the highest melting point of that group and the highest boiling point, and also has the highest heat of fusion and the highest heat of vaporization. And it is this phenomenon of hydrogen bonding that accounts for that observation. These unusual properties are observed because of the strong intermolecular force between water molecules. Now, the first thing I want to say about hydrogen bonding is that it's an intermolecular bond, right? What that means basically is that it's a force that exists between molecules. It's not a force that exists within the molecule. And let me just say that the term bond is a bit misleading, because when we talk about a bond, that's usually an attractive force between atoms. This particular phenomena is an intermolecular force that exists between molecules. And this type of interaction is formed between polar molecules that contain hydrogen, which is covalently bonded to a small electronegative atom such as fluorine, oxygen, and nitrogen. So if you have any molecule that has an F to H bond, or an O to H bond, or an N to H bond, any compound that has that particular structural feature can exhibit this observed phenomena of hydrogen bonding. Okay, now how does this work? Well, basically it's an attractive force, because what happens is that hydrogen is attached to one of these atoms, which would be very electronegative. In fact, fluorine, oxygen, and nitrogen are the three most electronegative elements that exist. And what will happen is that you're going to have a separation of charge here between the hydrogen and the fluorine, and as a result, the fluorine will have a negative charge, and it will attract a hydrogen atom from another molecule which will be positively charged. So therefore there will be a strong association between the two. So what this is highlighting here is the difference between a covalent bond between the hydrogen and fluorine atom and another covalent bond here. But here you have the hydrogen bond, which is an interaction between a hydrogen atom from one molecule and the fluorine atom from another molecule. So that is basically the structural feature that would lend towards the formation of a hydrogen bond between molecules. And that bond exists, of course, in H2O, right? So what we see here, if you focus on this one, for example, you'll notice that this hydrogen here, which is represented by the blue sphere, is attracted to the oxygen of another molecule, and that's a hydrogen bond right there. And you have that continuous linkage when you have several, of course, as you can imagine, there are billions upon billions of these molecules that exist within a sample of water. So you have that kind of linkage, which basically results in the properties that we observe. For example, water has a high boiling point because in order for the molecules to be separated from each other, energy is needed and a high temperature is needed to break the hydrogen bonding so that the water molecules can move freely and independently of each other. Okay, so that's basically it as far as this chapter is concerned.